Guys, so in this video you can see two engineers there. Like you all know, I'm engineer Happiness and engineer Joseph. So today we'll be talking on the components of the rig machine. This is the rig this is the rig machine, basically for borehole drilling. So today we'll be talking about the components. You can see the full structure of the machine, but yet to be completed. So these are the components. So my engineer here will talk mainly on the functions of this component you are seeing. So engineer.
Okay, thank you very much. It's my pleasure. All right, when you look at the rig she spoke about earlier, it's a borehole drilling rig, which can be used for borehole drilling. It can be used for soil test, soil integrity test. It can also be used for piling. So it's a rotary machine, right? Because it does its work in rotary motions. And when you talk about hydraulics, for hydraulic system to function, we have the engine, which is this particular diesel engine. We are using the Chinese diesel engine, as I said earlier, 22 horsepower. It's called 1115. That's the brand name. All right. Before me here, you have the hydraulic pump, and then we have the hydraulic control lever. Then we have the hydraulic motor. It's hydraulic motor. Now, how this works is the engine drives this hydraulic pump via pulley. You can see the pulley. This is a belt. This is a B belt. So made it B for better friction and tension. So this is it. Now, what this does, it pumps hydraulic fluid from a hydraulic tank. Let's assume this is a hydraulic tank. For the sake of the video, let's assume this is a hydraulic tank. So the pump pumps hydraulic oil from this hydraulic tank after passing through filtration. There's going to be a filter in between. So it pumps it through this control valve. This is a control valve. And this control valve, we have the pressure and we have the release. Now, this hydraulic pump have two ways. So one can be the suction and then one the supply, or the suction and the pressure. Depends on where this pulley is turned. When you turn it clockwise, the position changes. When you rotate it anti-clockwise, the position changes. So let's assume this is the suction. This pump sucks oil from here. Then with high pressure, this pump sucks oil from here. With high pressure, there's this mechanism inside that made it to pump or to suck the oil with pressure through the release. So then it now supply it to the control valve via hydraulic hose. So there's going to be a hydraulic hose that will connect to it. Now, and this in turn this is a two-way. So just like electricity where we have negative and positive. So you have the two units here. This unit is for one work. Assuming you want to drive motor, because we have a hydraulic motor, we have hydraulic piston or ram, depending on what you want to use it for. So when you engage this, it locks one way and open the other way to enable it to turn. So it can go clockwise and anti-clockwise. So then, while in idle, that is when you're not engaging this, instead of the pressure to stop, there must be a circulation. So the oil in turn return from here back to the tank when it's not in engagement. That is when it's not working. There's going to be an hydraulic hose that will be connected there back to the tank. So it's a complete circuit, just like electricity. It will be complete before it works. So that's just how it works. And hydraulic motors are very, very strong. Though the speed varies, depends on the made of the motor. So it can be slow, it can be fast. All depend on the rating of the motor.
If I get you correctly, you said